right, today we're going to be doing our review video for Chapter 9, Section 1. Chapter 9, Section 1. So as always, we always start with the learning target, and the learning target for today is to write algebraic expressions to determine any term in an arithmetic sequence. So we're going to be dealing with arithmetic sequences. We have some vocabulary words that we need to cover for this chapter. So here we go. A sequence is an ordered list of numbers such as 0, 1, 2, 3, or 2, 4, 6, 8, or there's many examples. We'll talk about specific ones in a little while. A term, a number, a variable, or a product of numbers or variables. So this is the fourth term, or the fifth term would be the fifth number in the sequence. So like here's the first term, second term, third term, fourth term, and so on. All right. A arithmetic sequence is a sequence in which the difference between any two consecutive terms is the same, so it has a constant difference between the terms, between consecutive terms. Common difference, the difference between any two consecutive terms is the difference between any two consecutive terms is as in an arithmetic sequence. Well, let's jump right in and do one here. State whether the sequence 23, 15, 23, 15, 7, -1, and 9 is an arithmetic sequence. If it is, they'd like to know the common difference. Well, as I look at that, I see 23 as it changes to 15. The difference between the two of those is 8. It went down by 8. As I go 15 to 7, the difference is a -8. We subtract 8. As you go from 7 to -1, the difference again is -8. As you go from -1 to -9, the difference is -8. So there is a common difference each time. It's -8. And it is an arithmetic sequence. All right, the next three terms, well, if it's -9 and I go down by 8, so -9 minus 8 would be -17. -17 minus 8 would be a -25, and a -25 minus 8 would be a -33. So the next three terms are -17, -25, and -33. State whether the sequence 29, 27, 25, 23, 21 is arithmetic. If it is, state the common difference. Well, as I look at it, from 29 to 27, it goes down by -2. 27 to 25, it goes down by 2. 25 to 23, it goes down by 2. 23 to 21, it goes down by 2. So it is an arithmetic sequence, and the common difference is -2. The next three terms, well, if it's 21 and I'm going to subtract 2, would become 19. 19 subtract 2 would become 17. 17 subtract 2 would become 15. So the next three terms are 19, 17, and 15. Write an expression that can be used to find the nth term of the sequence, 0.6, 1.2, 1.8, and 2.4. Well, I'm going to say that n is the number of terms, all right, and I can have one term, two terms, the first term, the second term, the third term, the fourth term, the fifth term, and so on. And the value of that is 0.6, 1.2, 1.8, 2.4, I'm sorry, 2.4, I wrote 2.8, correct that. All right, I want to look for the common difference here. Well, the difference between here and here is 0.6. It increased by 0.6. The difference from here to here is again 0.6 and 0.6. So each time it goes up by 0.6. I also want to look at the relationship between the term, which is these numbers, and the value. It looks to me if I took the term, which would be the number n, times 0.6, that would give me the value. I'm going to check a couple of places. 2, the second term, times 0.6, 2 times 0.6 is 1.2. That checks out. 3 times 0.6 would be 1.8. That checks out. 4 times 0.6 would give me 2.4. It looks like that's a good equation. So it's 0.6 times n. And for the next 3 sequence, so this is 1, 2, 3, 4, 5, would be 5 times 0.6 would be 3.0. 6 times 0.6 would be 3.6, and 7 times 0.6 would be 4.2. So the next 3 terms are 3.0, 3.6, and 4.2. Then an expression that can be used to find the nth term of the sequence 1.5, 3, 4.5, and 6. So I've got the term, all right, or the n, okay. I've got the first one, the second one, the third one, the fourth one, and so on. And it has a value of 1.5, 3, 4.5, 6, and so on. All right. Well, as I look at this, I can see the difference between here and here is 1.5. The difference from here to here is 1.5. From here to here is 1.5. I'm going to predict that there's going to be something about 1.5 times the term n. And as I look at this, if I take the term 1 times and plug it in, I get 1.5 times 1. So that works for the first statement. That checks out. If I plug in the 2 times 1.5 becomes 3. 3 times 1.5, it looks like my equation is going to work. So my equation here is 1.5 times n. If I say 1.5 times the fifth term, 1.5 times 5 is equal to 7.5. 1.5 times 6 would be equal to, sixth term would be 9. And 1.5 times 7 would be 10.5. 10.5. So there's the next 3 terms. Here they've set up the table for me. They say that, well, that the arithmetic sequence shows the cost of a taxi ride for 1, 2, 3, 4 miles. What would be the cost of a 9-mile trip? So I need to figure out 9. So I need to find my equation here. As I look at the difference between here and here, it's 1.75. The difference between here and here is $1.75. The difference from here to here is $1.75. So that looks like it's going to be the n times 1.75, but that doesn't work for my first value. I'm short. I need to have something more than just that. So it's going to be n times 1.75 plus some more. And if I look here, if I just do 1 times 1.75, and I get, I'm supposed to have 5 1/4, and I do $1.75 here. If I subtract, I get 3.50. So I'm 3.50 short there. Here I would be the same 3.50. So I'm going to need to add plus 3.50 to each of my cells. So checking out, let's try 3. 3 times 1.75. 21, 22. That'd be 5 1/4 plus 3.50. That'd be 8.75. That does check for 3, so I'm pretty sure my equation's good. And I'm going to plug in n. I'm going to plug in 9 for n. I'm going to say 9 times 1.75 plus 3.50. So 9 times 1.75. 45, carry the 4, 9 would be 63, 67, carry the 6, 9, and 6 is 1575 plus the 350. Be 1925, 1925. Similar problem here, different values, so we do need to do the math again. All right, it is $1.50 difference here, $1.50 difference here, $1.50 difference here. So I think we're going to have an equation that involves n times 1.5, but I do need to add some more. I think I need to add 450 to each one to get it to balance, 450 to get it to come up. So a 15-mile road trip, 15 times 1.50 plus 450. 15 times $1.50 would be $22.50 plus 450 be $27. All right. Which expression can you use to find the nth term of the following arithmetic sequence where n represents the number's position in the sequence? Well, if I look at this, the difference here is 3. The difference here is 3. The difference here is 3. Okay. So I know it's going to have something to do with 3 times n. 3 times n. If I look at this first one, if I try 3n into the first one, if I put 1 in there, I get 1 times 3 is equal to 3, but of course my answer is only 2, so I need to subtract 1. So I think my final equation is going to be 3n minus 1. I'm going to try that for, say, this one. 3 times 3 would be 9 minus 1 does equal 8, so it checks out. So the nth term would be 3n minus 1. The answer is D. D. Let n represent the position of a number in the sequence 7, 11, 15, 19. Which expression can be used to find any term in the sequence? Well, I see the difference here is 4. The difference here is 4. The difference here is 4. So it's going to be something 4 times n. But I do need to add 3 to get the first one to work out. I'm going to check the second one, so I'm going to put 2 in. 2 times 4 is 8, plus 3 would be 11, so it checks out. So I think it is 4n plus 3. 4n plus 3 is letter D. All right. Thank you.